Okay, hopefully you can see me now. Yes, I can see that 30 of you are on YouTube, so that's good. So, of course, I need to learn to see, to look at this camera or not the laptop. Okay, I will try to learn that. Okay. Okay, so today I want to continue a little bit of teaching about trigonometry. And then, okay, sorry, I have to also mute myself, otherwise that would be trouble for you. Let me see. Okay, I mute myself on Zoom, okay? So you, in principle, should be able to hear me through YouTube. And if you have any questions, you go to Zoom, just open your microphone there and talk to me, okay? Because if you write something as a chat on YouTube, that's far away from me. I cannot see that, okay? Okay. So if you remember, we talked about sine, cosine, and tangent of acute angles in a right angle triangle, and then we were solving some problems. So I mentioned 2 problems on the board, 3 problems on the board. I had time to solve one of them, but I couldn't find to solve the other 2. Okay, so let me just repeat them here, and then I will add some more exercises to sit down and practice on the problems. Okay, and please do not waste the time, because the exam would be close. And there are many problems in geometry part, okay? Okay, so that was one of the problems. Let me just do it here again on the board. One of the problems that I mentioned last time, but I couldn't find time to solve it, was this problem, yes? So we have a right angle triangle here. Yes, this was given to be 90 degrees. This angle is given to me 60 degrees, and this is 50. And I assume that every length is expressed in centimeters, okay? And then I have also another right angle triangle here. So here, this is 90 again. And then I have this. And this angle was given to be 65 degrees. And then this was my x. So by looking at this picture, and of course I need also my calculator, because these are the numbers that I have to use my calculator to be able to answer them. And if you remember, we were supposed to answer x in 1 decimal place. So round it up to 1 decimal point. Okay. So I have 2 right angle triangles involved in this case. My goal is to find this x. Of course, it is clear that this x is the length of the hypotenuse of this right angle triangle. But of course, I have only one angle is given, so I do not have any other information given in this problem. Okay, so it means that this motivates me at least to get some extra information about this triangle, so that I can use sine, cosine, or tangent possibly to answer for x, to get an answer for x. But of course, because this x is the hypotenuse, and you remember that sine is equal to the opposite side divided by the hypotenuse, and cosine was the adjacent side divided by the hypotenuse. Tangent was the opposite one divided by the adjacent one. So tangent is probably not that useful here, because tangent of 65 degrees will be involved with this side, which is opposite to 65, and this side, which is adjacent to 65. So I do not have any information regarding this. I do not have any information regarding this. And of course, it is not involved with this x at all. So it means that I shouldn't probably start thinking about tangent, because it doesn't work. Okay, so there are other 2 choices, either cosine or sine. For example, let us focus on sine first. If I want to use sine, then it means that this is equal to the opposite side divided by the hypotenuse. So if I want to use sine, it means that I need to know the hypotenuse of the adjacent triangle. So it means that, first of all, I need to have something about the hypotenuse of this. So let me call this one y. Still, I don't know it, but let me see if I can find it or not. Now, I change my focus. I switch my focus to consider this triangle. And this 50 is the opposite one, and this one is the hypotenuse. So it becomes clear that might be I should use the sine of 60 degrees in this triangle. So let me name them. So if I assume that this is A, B, C, and D, I am concentrating on the triangle ABC, and I am saying that sine of 60 degrees is equal to the opposite side, which is 50, divided by the hypotenuse, which is y. Do you remember I told you the trick in next session? If you have something like this, if you want to, you can interchange these two. And here I want to, because my goal is to find y, so it's a good idea to interchange two if possible. I told you that this is possible. Okay, so this means that this is a quicker way of doing things. So y becomes 50 divided by sine of 60 degrees. Okay, so this means that I am done. If I want to, I can put this number in my calculator and divide 50 by sine of 60 degrees. I get a number that is my y. Okay, so if you do that, I don't know, if you calculate this, I would prefer to keep it in this form, but it might be for you at this level to simplify this, okay? So if I calculate this, so I will take my calculator and I will calculate this. So this is 50 and divided. Make sure that your calculator is in the degree mode. Let me keep 2 decimal places for the time being, centimeters. And then I will round it up to 1 decimal point. Okay. In principle, I shouldn't write exact value, so I should write approximately equal to that. Okay, now I go to the triangle ACE. What can I do? Again, I can write sine 65 degrees is equal to the opposite side, which is y in this case, divided by the hypotenuse, which is x. Yes? But again, I am looking for x. So this tells me that if I want to, I can interchange these two, as I told you before. So this becomes x equal to y divided by sine 65 degrees. Okay, so then what I do, instead of y, I put this number that I got here, and then divide it by sine 65 degrees. Okay, so I will take the same number in its entirety from my calculator and just divide it by sine of 65. Yes? And I get this answer, and I will round it up to 1 decimal point. So x becomes equal to, so sorry, let me write it properly. So x becomes approximately up to 1 decimal point is 63.7 centimeters. Okay. But what I want you to also learn, so this is the answer. If you have any questions, you can open your microphone and talk to me. No questions? Okay, good. So this is one way of doing that. So it's also good, even though I don't want to force you to learn it at this level, but I think it's also good to work with these trigonometric ratios without simplification or anything, with giving me exact values. So for example, this is the exact value for y, okay? So I can replace this y here.
You're freezing from time to time.
Okay, so that's good to know about these things. Let me see what's going on. Might be this is from my internet. Yeah, please inform me about these things whenever this is going to happen. So let me try to see if it is going to work. Might be because I am using a lot of internet, doing different things. Yeah, please let me know if this happens again. So might be, if this happens again, I will actually do something more, okay? Okay, so I want you to learn also that you can just work with these ratios. You don't have to replace the approximate numbers unless it is mentioned in the problem itself, okay? So yeah, let us practice this a little bit. So you realize that y is this number. It is written in a fancy way, I agree, because this is approximately this number, but this is the exact value. Let us work with this. It's a fraction now, okay? Whose numerator is just a number. The denominator is also a number, but expressed in this form. And then we know that x is equal to y divided by sine 65 degrees. If I want to work with this trigonometric ratios, what should I do? So I would say that x is equal to, instead of y, I can put this expression. So it becomes 50 divided by sine 60 degrees divided by sine 65 degrees. Yes? So I want you to learn that there is nothing mysterious about sine, cosine, and tangent. They are just numbers expressed in a symbolic way. Yes? So here I would say that if I have a over b and I wanted to divide it by another number c, do you remember I told you that you can give a denominator equal to 1 to this and then multiply these numbers which are far away from each other. It becomes a times 1, it is a, and then you can multiply these two numbers which are close together and put it in the denominator. Yes? So it means that it is a divided by bc. So this number can also be written as 50 because 50 is now playing the role of this a. 50 should be in the numerator. And then b and c should be multiplied together. This one is playing the role of b. This one is playing the role of c. So this becomes sine 60 degrees, sine 65 degrees. So if I ask you what is the exact value of x, a little bit cumbersome, yes? But this is not very strange, so you shouldn't be scared about what you write here. This is the exact value of your x, written in this fancy way. So I want you to learn just these things are just pure numbers. If you really want to get rid of these numbers, you need to put them in your calculator and do the calculations. So sine, cosine, tangent are just numbers. Okay. Is the freezing problem solved or still it's there? Am I still freezing? It's not that cold here so that I freeze actually.
No.
Okay, good. It's good. Thank you. Okay. So this is one of those problems. Hopefully, yeah. Please, I cannot just repeat it. Whenever you don't understand something, please interrupt me. Yes, pardon? May you repeat, please? Okay. So, yeah, please, whenever you feel something strange going on, please interrupt me, okay? By just talking, I cannot see. You are chatting a lot. I don't know. Are you chatting?
It's a better quality now.
Yeah, okay. Thank you very much. Yes. Okay, so let me now solve the other problem. If you remember, this was one of the other problems left on the board. So I have a right angle triangle in this form. this is x, this is the 90-degree angle here, and then we had another 90-degree angle here, yes, and it was given to be 5 centimeters, this length. This was given to be 30 degrees, and then this is supposed to be calculated, x. This length is supposed to be calculated. Okay, let me give these points name, and then we can talk together actually. So this is A, assume that this is B, let me call this H, and let me call this point C. If you have any opinion how to solve this, you can talk to me now, okay? Do you have any idea how can I find X here? No ideas?
Could you not like you have 90 degrees and then 30 degrees, and then you take like what's left from the angle?
Okay, so you mean you are talking about this angle, am I right? Yeah, that is probably a good idea. So what you are saying is that this big triangle is given to be this angle. You see, this angle is not necessary to talk about. Yes, you don't need to talk about this one because you already have an information about it. So why you really want to do that? So I mean that this is very important. I am not saying that this is wrong. Might be you find this one and use this one to solve your problem. But this is very important to learn not to write what is not necessary actually. Because what you need here is an angle and one of the length, one of the sides of the triangle. Okay, so if you concentrate on triangle ACH, you have one angle, you have one side. So might be this is not useful to start talking about this, even though you are right. This is also 60 degrees. But I would say that it is better to write this one to be 60 degrees. Because now this is in another triangle. By the way, why this is a 60-degree angle? Because the bigger one is a right angle triangle. So this means that when this is 30, this is 90, the sum is 120. So what is left for this one is 60 because the sum of the angles is supposed to be 180 degrees. Okay, so this is why this is 60 degrees. Okay, and then what will happen actually? This is a very simple problem now because what you need is just the sine of 60 degrees. You see, it was very simple. If you want to write this 160 and then try to make it a little bit complicated, it will probably work, but this is much easier. Because now I really don't need to write anything more. I can just concentrate on this right angle triangle. So do you agree that this is a right angle triangle? This is given in the picture to be 90, so it is clear that this one is also 90. Yes? So then I would write in this triangle AHB. I write sine, cosine, or tangent of 60 degrees. Which one is better here? Because the side that I have it is 5, and it is opposite to 60. So I have opposite. So it means that probably cosine is not useful. And then the other side, which I want to find is x. It's sine, yes. It's sine of 60. So I will use sine of 60. So sine of 60 in this triangle is the opposite side, which is AH, which is 5, divided by the hypotenuse, which is x. You see, it was very simple. You just need to be a little bit patient. That's my advice. Don't start writing all of the ratios to see which one working. It's better to just take a little bit of time to think logically about the problem and then start writing. Okay? So you see that was very simple. If you are patient, it was very easy to find that this angle is 60, and instead of focusing on this big triangle or even focusing on this small triangle, I will focus only on this triangle and my problem is solved, because again, I can interchange these two according to what I told you. X becomes 5 divided by sine 60 degrees. If you want the exact value, this is your exact value. If you want to have some approximations, you need to put this number in your calculator and then round it off according to the problem by 1 decimal point. So let me just do that. So it is 5 divided by sine 60 degrees, yes? So this becomes sine 60 equals to, it's 5.77, etc. So I'm supposed to round it up to 1 decimal point, so it becomes 5.8 centimeters approximately. So you see, this is the importance about these kind of problems. You need to find the best way, the simplest way. But of course, if you make it harder and finally you are able to get this correctly at the end, it doesn't matter, you will get a full mark in the exam, because the point is that to be able to get this by logical, by valid way of doing things. Okay, any questions here? Okay, let me, there is also another good problem here. Might be we can consider it an A-level problem. So let me write it down here for you. So the picture is something like this. If I can draw it carefully here. So I have a right angle triangle in this form. This is 90 degrees. And then I will go up here. So I will make another 90 angle here. This is also 90. I make another 90 degree angle here. This is also 90. And then I will continue this so that these two lines intersect at a point. So let me get rid of this extra part. I don't need it. Okay. So let me give these names A, B, C, D. Okay. And then this angle is assumed to be given, and the name is theta. Any angle, for example, 70 degrees, 75 degrees, whatever. Assume that theta is given to you, and then you are supposed to calculate x. Okay, of course, you cannot expect to get a number for x because theta is given as just theta. I don't know the exact number for theta, but I want to find a formula so that expresses x in terms of.
Excuse me, I need help to find the link because I can't find the link.
So why didn't you mention it from the beginning? So you need to go to the chat window. Okay, so you cannot hear me, yes? So let me see. Who is asking? Who is asking about the link? Okay, Abdul Manan, and now you can hear me, yes?
Yes.
Do you see the chat window?
You mean the chat in Zoom?
In chat in Zoom, yes?
Yes, I can't find it.
Yes, and then if you go a little bit higher, you see the link there, yes?
I can't find it. It's just.
So let me send it once more. Control C if I can find it. Now, did you?
Oh, no.
Okay, so please turn off your microphone and go to that. Okay. Thank you. Okay, so we'll go back. Okay. Now we want to. So is the question clear? I want to find a formula which expresses x in terms of trigonometric ratios of this angle, assuming that that angle is given. Okay, so I have 3 right angles involved. This one, that one, and this one. So how we should do that? So I would consider this probably an A-level problem.
Wait, so what exactly is x? Where is x?
X is from here to here. From B to C. Yes?
Oh, okay.
So somehow you have this experience that I need to know an angle here, because this x is the length of this side. Can I know something about one of these angles? So let me choose a color here. So this triangle ABC, one of the angles is this one. One of the angles is this one. One of them is expressible in terms of theta. So if I give you theta, you can immediately find one of these angles.
In the triangle ABC, the angle A is theta.
Yes, this one, this red one here is theta. Why is that the case? Because let me write it as A1 and A2, for example. If I ask you what is A2, angle A2 plus angle theta, this becomes 90 degrees, yes? Because in this triangle ACD, the angle A2 plus angle theta plus this angle is supposed to be 180. This is already 90 degrees, so the sum of these two angles is 90 degrees. Okay? And also know, you see that because this angle is also given to be 90 degrees from the beginning, the A1 plus A2, if I add A2 and A1, the answer is also 90 degrees. Okay, so this means that A2, I can conclude that, so let me write it in this way. So I can conclude from these two, this will imply that, let me write it here, A2 plus theta is equal to A2 plus A1. Yes? And now this A2 and this A2 can be cancelled. How? Because I am adding minus this angle to both sides, and that's cancelled. And what is left is theta equal to A1. So it means that if someone tells me that this angle is theta, by just looking at the geometry in the picture, I can realize that I can name this one theta as well. So that's also theta. Now that is theta, and then I can focus on this triangle, try to find this x. This x is the opposite one, yes? So it means that the opposite should be involved, okay? But still, I need one extra information for this triangle. Okay, the only way that I can get an extra information about this triangle is just working on here, because I need to find something sharing between these two triangles, and this is the only one that is shared between these two triangles. So it means that I go back to this triangle and I see that this one is the opposite one. Okay? So how can I calculate that one now? Might be... So how can we calculate that angle now? So nothing. So let me see if there is any extra. So yeah, I told that this is not going to work. Sorry, I have forgotten to write that this is also 10. And again, everything is in centimeters. I forgot to write 10 on top there. So I was thinking that this is not enough to solve this problem. Okay. Now everything becomes clear. So what I have written so far is completely correct. Now I will go here and try to find this length. Okay, so let me call this one y. Still, I don't know why, but I know something. I know tangent of theta is the opposite side. So in triangle ADC, tangent of theta is equal to the opposite side, which is y, divided by the adjacent side, which is 10. And I am looking for y, and then I use the same trick. I can interchange these two, yes? Sorry. I just multiply by 10 because I want to make y alone. If I multiply both sides by 10, this becomes 10 tangent theta is equal to y. So this is the value for y. Now I go back to my triangle here, triangle ABC. What can I write? Again, I can write tangent of theta. Tangent is not useful, is it? No, because x is opposite, so sine is useful here. Sine theta is equal to the opposite side, which is x. I don't have it yet. Divided by the hypotenuse, which is y. So I can just write it here. But now I can take this y and put it here. Yes. So this becomes x divided by 10 times tangent of theta. Okay, let me write what I have on top here. So I got this relation. Sine theta is equal to x is in the numerator, 10 times tangent theta is in the denominator. My goal is to find x. Do you remember I told you that sometimes it is we have more than one variable in the problem. I told you even in the exam, for example, I gave you an equation involving many parameters. Then I ask you to solve for x. Here, this is one of those problems. Here I have two parameters, two variables. One of them is theta, the other one is x. But my subject is x. So I can say solve this equation for x. What I want you to understand is that there is no essential difference between this equation and this equation. I am sure that if I ask you solve this equation, you know what to do. You immediately multiply both sides by 2 because your goal is to make x alone, and then x becomes 10. I want you to really understand that there is no essential difference between this question and this question. Even though this is written in a little bit horrible way, but this is exactly the same, because I told you from the beginning, assume that theta is given to you. If theta is given to me, I put sine of that theta in the calculator, it becomes a number, usually a decimal number, okay? And then I put this tangent of theta in my calculator, it becomes a decimal number. I multiply it by 10, usually it becomes another decimal number, okay? So then I have a decimal number, I don't know, say 5.2, I don't know. Of course, this is not the exact value for this. Assume that 0.2 is equal to, then I have x divided by, for example, 10 times that tangent alpha, for example, is 1.3, for example. And then I ask you what is x. What you do, you just multiply these two numbers to get x. Yes? And that's the same story here. I want you to really understand this thing, not just memorize them. So I want to make x alone. So what I do, I multiply both sides by this expression. So then the left-hand side becomes 10 tangent theta times sine theta is equal to x. This is my x in centimeters. So this is a good way of algebraically doing something. For example, if I say theta is 30 degrees, find x, you don't need to think about all of these things again. You just put 30 instead of theta and put it in your calculator, you find x. If I change my mind and I say that, no, this angle is 75, okay, you really don't need to redo it again. You just put 75 instead of this. You put tangent 75 in calculator. You put sine 75 in the calculator and multiply 3 numbers, you get x. So this is what is expected in this problem. Any questions? Okay. Now, let me clean this. So let me solve another problem for you here. Of course, in the book there are also good problems, so I want to finish a little bit from now so that you can start working on the problems yourself. So I just mentioned, because drawing the diagram is not that easy. So here there is a woman standing on a hill. Okay, so assume that, I don't know, this is the hill, and then she is looking at the flagpole, for example, and this is the flag, for example, Sweden's flag or whatever. And then we know that, for example, it is 60 meters. No, it's too long, yes, because it is written 60 feet. So around 20 meters, for example. We know that. And then this person who is actually here, yes, and then, so the horizontal level is this level, and then what she's looking at, this angle, okay, I will talk about these angles. This angle is given to be 40 degrees, and this angle is given to be 18 degrees. And then you're supposed to find this distance, the distance from the person to this flag here. So we are supposed to find this value x. This is wanted. So this x is wanted, okay? There are two names for these two angles. I want you to learn about them as well. This is the horizontal line, and this is the line of your sight when you are looking above the horizon. Yes, this angle is called angle of elevation. Yes. So let me write with a different color, so it might be, this is not that visible. So this is called angle of elevation. So it means that angle of elevation is the angle that your sight of the line of your sight makes with the horizontal, but it is above the horizontal. This angle, on the other hand, that the line of your sight makes with the horizontal, below the horizontal, is called the angle of depression. So angle of elevation, angle of depression. So these are just names. It is good to know about them. But the point, it doesn't matter if you know the name or not, but you're supposed to be able, given this information, solve this problem. So these two angles are given to be 14 and 18. The height is given to be 20. You are supposed to find this distance. Okay. You are supposed to find this distance. Okay, so what should we do here? Okay, any idea you can share it with me? Talk to me. How we are supposed to find this distance from here to here? This is a little bit hard problem, I think. But these kinds of problems are also in the book. Yeah, I can give you some minutes to think a little bit about 5 minutes, for example. Of course, I cannot pause the live stream. But anyway, we can just wait for 5 minutes. Okay, do you have any idea how to solve the problem?
Well, I started by writing cosinus of 14 degrees is equal to x divided by the hypotenuse.
Okay, so let me correct you at least. My feeling is cosine is not useful. Because if you say cosine, because you see my information, of course I don't have this part, I agree with you, but at least I know something about this. I really don't know anything about this. But at least I can be hopeful that I can somehow say something about this, because at least I know that this length is 20, even though it's not exactly this one, but it is more promising than working with cosine, which needs the hypotenuse, and I don't have any information with that. So this way of thinking, I want you to learn. I'm not saying that I'm 100% right. It might be the problem is complicated. I have to do some trial and error myself, but I would never start with cosine in the first place. Now, can you say at least, based on what I told you right now, which one is suitable if you want to start with?
Tangent.
Tangent is better. Why? Because this is 14 degrees. This side is adjacent to 14. Of course, there are two options left for me. Either work with hypotenuse, which I don't know anything about, or work with the opposite one. It's still I don't know, but at least I have some information about the whole length. So it's more promising. That's what I'm saying. Okay, so it's better to work with tangent. So let me give these names. So let me, for example, call this A. Let me call this point B. Let me call this point C, and this point D, so that we know what we are talking about. And then, if you don't mind, let me, for example, put this length y, which I don't know, of course. Let me give the name of this length to be z. If you ask me what is y, I don't know. If you ask me what is z, I don't know. But if you ask me what is y plus z, I know. It's given in the problem, it's 20. Yes? Okay, so let's be a little bit optimistic. So at least we realize tangent is better. Might be more promising. Okay, so I would start in this upper triangle, which is called ABC. I would write tangent of 14 is equal to the opposite side, which I gave it a name y, divided by the adjacent side, which was given the name x by the problem itself. Yes, so this is what I can write. Okay, and then hopefully it's more or less understandable. We can use more or less the same thing with this angle of depression as well. Yeah, so I can change my perspective to the lower triangle. That's also a 90 degree. So it's also a right angle triangle.
I can't see where the x is.
X is here. Okay, okay. So let me make it with black. X is from here to here. Is it visible now? From A to C is called X.
Yeah.
Okay.
That's good.
Thank you. Okay, so now the triangle ACD, what can I do? I can more or less hope that tangent will solve my problem somehow. I mean, from these three ratios, tangent is more promising. So tangent of 18 is equal to the opposite side, which is z, divided by the adjacent side, which is x. So it is z divided by x. Okay, so if I ask you how many unknowns are involved in this problem, you say three unknowns, sorry. I have three unknowns. One of them is x, the other one is y, the other one is z. But I haven't exploited the information that this length is 20. So it means that this is given for some reason. So in principle, I should be able to use this in an effective way to be able to find x. Okay, so you see the picture. In the picture, I know that y plus z is equal to 20. Yes? So I know that y plus z is equal to 20. These two unknowns are not my point. My point is to find x. But from here, I multiply everything, both sides, by x. If I multiply this by x, it becomes x tangent 14 degrees. If I multiply this by x and x are cancelled, and then I have y. I do the same thing here. I multiply both sides by x. What happens? It becomes x tangent 14 is equal to z. And then here, that I know that this is true because I see that y plus z is given to be 20. Instead of this y, I put that expression, which I realized is equal to y.
Did you mean 18?
Thank you very much. Thank you for correcting me. This is 18. Thank you. Yes. Instead of y, I put that expression, x tangent 14. Yes. And instead of z, I put x tangent 18. Equal to, instead of 20, I just simply write 20. Now let me ask you the question again. How many unknowns are involved in this new equation? You see, 14, tangent 14 is a number, tangent 18 is a number, 20 is also a number. We know about them. For example, for these two, I can put them in the calculator. So the only unknown left for me is just x. Okay, how can I deal with this equation now? This is something that you also know. If I give you this equation, I am completely sure that you know how to solve it. If instead of this fancy way of writing numbers, if I give you 2.3, for example, x plus, say, 4 times 2, I don't know why, x again is equal to 20. You can solve it, yes? You would say that 2.3x plus 4.2x, I add these two numbers. So it means that in your head, you add these two numbers together, 2.3 plus 4.2, and what you get, you multiply it by x. Okay? But it might be so simple that you don't go through this step, you just do it in your head. But here, I don't know the numbers. So the second method is this method is the only one that I can do. In principle, what I mean, I factor x out. Okay? So what I do, I factor an x out between these two. So I would say this. I write an x here, and I have to add these two numbers. Tangent of 14 plus tangent of 80. So what I want you to really understand, these are just numbers. The reason that this becomes a little big, because I don't know the numbers. Otherwise, I would put them here. If you want to, of course, you can put the calculator here, but I want you to learn working with exact numbers. Okay, now my goal is to find x. So I need to make x alone. And this is the coefficient of my x. So if I want to make x alone, I have to divide by this number. If I divide by this number, this is gone, x is left. I have to divide 20 by this number as well. Tangent 14 degrees plus tangent 18 degrees centimeter. If everything, oh, sorry, here, sorry, it is not centimeters. The units, the length unit is meters. So that is meters. This is the exact value. But of course, for practical reasons, it is not that useful. So in that case, you can put this number in your calculator and calculate it. But one thing about calculators, I'm actually very interested to see how you calculate this. So you need to write B20, use this division button. If you write this in your calculator, this answer is not what we mean. So be careful. If you just punch these things in your calculator, you get the wrong answer. Okay? Because if you punch this in your calculator do this, divides 20 by only this part. When it got the answer, it add the answer to tangent 18. But this is not what you're supposed to calculate, because the whole expression is a number and you are dividing 20 by the whole expression. So you need to use brackets on your calculator. Okay, so you need to punch this in your calculator in the degree mode so that you are able to get the correct answer. Okay, so I want you to do it at home. I want to find this, but of course this is the exact value. If I want to do approximations, I have to put this in the calculator. Please do it at home if you have a calculator available, so that you can check your answer against mine to see that you are on the right track. Okay, so 20 divided by brackets open using my calculator, and then I have tangent bottom of 14 plus tangent bottom and then 18, and then brackets closed. Okay, and then I press the equality or execute button. Okay, then what I get is 34.82, etc. And if I want to keep only one decimal place, so that would be approximately equal to 34.8 meters. Okay, I want to make sure that every one of you know how to calculate using the calculator. Okay, because in this exam, mostly I will ask you to round the numbers up. Okay, even if you are not very happy with this kind of calculation, you can put these numbers there and use your calculator more effectively. But of course, if you do something here, you make an error here. If you do it here by approximation, you make another error here, and then you are accumulating the errors unless you really know what to do. So this is my preference. I usually find X exact value, and then at the end, I put this in the calculator. Then, of course, I have only one error to take care of. Okay, so hopefully you are able to get this number. Okay. Okay, so I just gave you some examples. So that was good to understand. So you need to broaden the point of your the way that you look at the problem. Yes. So you see, it was a little bit convoluted. I couldn't use directly this information, but I realized that let me break it into two parts. And then I know this equality, I found these relations, combine them into this equation, then I will get an equation with just one unknown, and that's my goal. I can just find it. Okay? Okay, so let me just clean this one now. So I want to finish the lesson now by just giving the last part, which is on page 270 in the Origo Math 1C book. Okay, so if I ask you, for example, this is one of the angles that I have it in my memory. If I ask you sine of an angle, someone gave me this. Someone told me that the sine of this angle is 0.5. Then might be I'm curious about what that angle is. This number is so famous for me, I have worked with it a lot, so I know that this angle is 30 degrees. But assume that someone tells me this, sine theta is equal to 0.6. This is no longer famous for me. So is there any way to find theta? For you might be, this is also not famous. At least this is famous for me. I'm able to really know that that is 30 degrees, okay? But assume that this is given to me. I really don't know what that angle is. I need to find it. I want to find a way to find this angle. They might ask the same question for cosine. They might ask the same question for tangent, yes? They might ask me, what is that angle alpha, for example, whose cosine is equal to, say, 0.75, for example. They might ask, what is the angle beta whose tangent is equal to 2.3? What is alpha? What is beta? So this is expressed in actually page 270 on the book. So I want just to tell you what you need to do. This is important to have your calculators in front of you. So if you go to your calculator, there is a sign button on the calculator. Above the sign button, so for example, if this is your calculator, it's written sin here. On top of that, you see sin -1. And then the same thing for cosine. You have cosine -1. And then you have also tan, and then you have tan equal. Okay. Unfortunately, that is an unfortunate symbol that I will talk a little bit about that, why this is an unfortunate one, but this is ubiquitous in mathematics. Most of the time people use that notation. This is called sine inverse. Sine inverse. And this is called cosine inverse, and that's called tangent inverse. So if I want to answer this question, I don't know, you have a second key on your calculator called second or shift or whatever. If you press that button and then press sine, actually sine will not work. This upper one will start working, yes? So if I want to answer this problem, I would write theta is equal to sine inverse of this number, 0.6. So you see, if someone asks me what that angle is, that angle is sine inverse of 0.6. Then the best thing that we can do is just put this number in the calculator, but you need to know what to do, yes? So you press this shift button or second button or whatever, and then you press the sine button, but this shift will make this one come into action. And then in front of it, you put 0.6 and execute. Then you will get a number. So please try to make sure that you do it properly. So if I want to answer this one to you, for example, up to 1 decimal point, what I can do, I can write shift sine, and then I would write 0.6 and then execute. So this gives me 36.86. So if I round it up, it becomes 36.9. If I have switched my calculator into the degree mode, this answer will be in degrees. So you see, it's a little bit bigger. For example, for this case, let us check. If I ask you what is theta here, you would say theta is sine inverse of 0.5. If I punch this in my calculator, you will get 30 degrees exactly. And you see that when I increase this number a little bit, the angle is also increasing a little bit. But this is not always the case. It might happen that I increase the angle, but the ratio goes down. For sine and tangent, this doesn't happen. For cosine, this happens if you are working between 0 and 90 degrees. Okay, let me do this one for you. If I want to find alpha, so tell me, what should I write? I should write alpha is equal to, because this is cosine, I have to write cosine inverse. And then I put this number inside, 0.75. So let me just do that. So what I need to do, I need to write shift cosine inverse in front of it, 0.75 equal. So this gives me 41.4 degrees. Of course, this is approximately, so let me fix it. This is exactly equal. This is exactly equal. But if you want to write it, this is approximately equal. And if I want to answer this one, what is beta? Beta, because this one is tangent, you need to write tangent inverse of 2.3, okay? This is the exact value again. So let me just calculate this one as well. So this is shift tangent, which is tangent inverse now, and then you have 2.3, it's equal to 66.5, approximately 66.5 degrees. Any questions about the meaning and how to use your calculator? It's important to know how to use your own calculator. Might be the point, the places, and I don't know, some names are different. Might be in some calculators called shift, I don't know, but mostly it's right second. Any questions?
Are we gonna learn like what they mean further on, or?
Inverse trigonometric functions, these are called inverse trigonometric functions, is a little bit complicated subject. I would say no. In high school and Swedish system, you don't talk about very exact ideas of these functions, okay? But so that's what you just need to know at this level. But there are some points that I want to mention. Why I told you that this is an unfortunate notation, because you know it's extremely important, don't get confused. If I ask you if I ask you 5 to power minus 1, can you give me what is the answer 5 to power minus 1? You should remember about negative powers. So what you write is 1 over 5 to power 1, which is 1. And if you want to put it in decimal points, this is 0.2. So, but let us concentrate here. 5 to the negative 1 is 1 over 5. This is why I'm saying that this is an unfortunate symbol, because you might think that sine inverse somehow of 0.6 means 1 over sine 0.6. Yes, I would say that might be you have right to assume this, but this is not the case. So that's why I'm saying that this is not a very good symbol. But anyway, because it doesn't, actually it's because another proper name for this, instead of sine inverse in some books, you see people write arc sine. Okay? A-R-C, arc sine, instead of this one. I would prefer this symbol because there is no matter of confusion. On the other hand, this also has a meaning, because that's an inverse function, and that's also standard in mathematics, that if you want to denote a function, inverse function, you use this symbol. Okay, but let me, at least when you know what you are doing, you are not confused. Make sure that you understand sine inverse, cosine inverse, tangent inverse is not this exponent. Because if it is an exponent, I can write it in that way, but make sure that you understand this is not an exponent. This is read inverse, okay? Sine inverse of 0.5, sine inverse of 0.6 is the number that if you punch this in your calculator, you get an answer. Okay, for cosine inverse, some books, they write arc cosine. And for tangent inverse, some people write arc tangent. So these are also some names that you might see in different books. Okay, but I haven't seen any calculator using these symbols because actually they are too big. Might be you cannot fit them in a proper place. Okay, in this space. But you can see in many books they are using this, but not on calculators. At least I haven't seen calculators using this. Okay, there is another point that I just want to mention. So, for example, let me just solve one of the problems in the book. Okay, so this is problem 72, 41, page 270. Okay, so you are this triangle is given to you. Part B. I am talking about part B. Okay, so this a triangle of this form. Oh, sorry. A triangle of this form is given to you, something like this. This is 90 degrees. This angle is given to be u, which is your unknown angle. But this time, the hypotenuse is given to be 52, if everything is in centimeters, for example. And then this is given to be 24. And this is the first time that in these trigonometry problems, an angle is wanted. So if you remember all these problems that I was talking about so far, we were dealing to find the length. An angle or some angles were given to me, and I was supposed to calculate the length of a length of one of these, for example. One of these lengths of this triangle or any other triangle. But this is the first time that two sides are given and an angle is wanted. Whenever an angle is wanted, you need to remind yourself about sine inverse, cosine inverse, tangent inverse. Which one to use depends to the problem. So, for example, which one is useful for this case? This is my angle. The opposite one is given. The hypotenuse is also given. Adjacent hypotenuse, this reminds you of sine. So it means that I need to write sine inverse, I need to write sine of u is equal to the opposite side, which is given to be 24, divided by the length of the hypotenuse, which is given to be 52. So, of course, it is not mandatory, but let me simplify this fraction. If I divide it by 4, it becomes 6 times. If I divide it by 4, it becomes 30. It doesn't matter here. So what I realized that sine of u is equal to 6 over 13. Okay? But my point is to find u, sine is given. So it means that u is exactly equal to sine inverse of that number. 6 over 13, and this answer is expressed in degrees. But of course, if you want to have an approximate value to get a feeling about the size of that angle, you have to punch this in your calculator. So how do you punch it? So you write, I don't know, shift, then you put the sine button, but because you have pressed shift, sine inverse would be in operation. And then you need to open a pair of brackets. You need to write 6 divided by 13, and then brackets closed. So this is the way that you need to punch this to find an approximate value for your angle. So let me see. What should I do? So I shift, and then I press the sine button. I open a pair of brackets. 6 divided by 13, brackets closed, and then equal. So what I have calculated is 27.48. So if I want to approximate this is approximately up to 1 decimal point is 27.5 degrees. So this angle is approximately of this size. Okay. Okay, so I will stop here. More or less everything what I wanted to talk about trigonometry is finished. I can fix a little bit of it tomorrow, and then everything is covered until page 271. Okay? So there are many exercises in the book. They are good exercises. I want you to spend a little bit of time at home as well, because otherwise you will not be able to finish all these problems. So what I want to mention is that the trigonometry starts in the book from page 264 and ends on page 271. 7 pages. And it contains 3 sets of problems. So please start working on them. If you don't have any questions here, if you have, ask me first and then go to that one. Because I want to, I don't know if this is a good idea or not, let us check that. Because I want to end this live stream and then we can go to Zoom. But the problem is that if you have a question, I want to write it on the board. Might be it is not that visible for you, but then I will try to write it very big that you can see. Okay? Any questions?
I have a question.
Yes, please.
What was the other way to note the inverse of sin?
Arc sine. For example, here, if I want to write it down, sine of u is equal to 6/13. I would say that u is equal to arc sine of this number. So sometimes if you see other books, might be they have written it in this way, but this is not in your book. Is that your question?
Okay.
Yes?
Yes, thank you.
You're welcome. Okay. So I will end the live stream, but I will remain on Zoom until 1 o'clock. So please, you can just have a quick break, 2 or 3 minutes. That's up to you, of course, because you need to finish practicing. And then start practicing. If you have questions, please ask me through Zoom, and I will try to write it a little bigger so that you can see, even though the quality of Zoom would be much lower. This is why we are actually doing this live stream on YouTube. Okay, thank you very much. We go back to Zoom.